spot where we were last week. So if you want to get your notes out, that packet I gave you, does anybody need, oh, you found it. Perfect. Yep. If you need a packet from last week, there are, everything that I always pass out to you guys is going to be in that black hanging file on the wall. You can find it. All right, so if you want to look at that front page, all the definitions that we talked about last week, you can use those to answer these questions, and then we'll get to our next set of definitions after we go through them. All right, so for the first one, the age of every 10th person who walks into Kohl's, is that a population or a sample? It is a sample. Not everyone included in that. Okay, the next one's a little tricky. Just put an S there. The survey of 357 teachers in Stark County found that 82% of them had a master's degree. So you kind of have to know how many approximately teachers there would be in Stark County. I can tell you at our high school alone, there's probably about 100. So maybe that changes your answer potentially. Population or sample? It's a sample. There are more than 357 teachers in Stark County for sure. Okay, determine whether the value is a parameter or a statistic. So parameter goes with population, statistic goes with sample. It says a recent survey of alumni at a major university indicated that the average salary of 10,000 of its 300,000 graduates was $125,000, we're assuming there. Okay, so is that a parameter or a statistic? It is a statistic. It's based on a sample of the graduates. The average salary of all assembly line employees at a certain car manufacturer is $33,000. So the fact that the word all is there tells me it's a population and therefore a parameter. Okay. Identify whether the statement is inferential or descriptive statistics. So descriptive statistics, remember, is where we just kind of lay out our information. We do our calculations, we make our graphs, that's it. Inferential statistics, oh, you need something. Inferential statistics is where you make the leap. You make a decision or a conclusion about the statistics that you have. So it says the average age of the students in a statistics class is 21 years. Is that descriptive or inferential? What do we think? Is there any sort of inference, conclusion, leap made from that data? It's strictly just data, a calculation. So it is descriptive only, okay? From past figures, it is predicted that 39% of the registered voters in California will vote in the June primary. What do you think about that one? Descriptive or inferential? That's inferential because we're taking past figures and using that to make a decision or a prediction or a conclusion about something that will happen in the future. Okay? Questions on any of that stuff? Just kind of recap from last week. All right, so that Math Excel due tomorrow or tonight, actually. Okay, so 1, 2. So if you want to flip your paper over to the next set of definitions that we're going to get to today, we're going to talk about qualitative versus quantitative data. And then we're going to talk about the different levels of measurement that you can have when you're looking at data. Okay, so first, qualitative versus quantitative. Qualitative data is information that cannot be expressed as a number for the most part. And when we say number, we mean a quantity, okay? And that's why quantitative data has its name. It represents a quantity. Quantitative data is data that can be expressed as a number or can be quantified. If you're bouncing between the two and you're not sure, an easy, I think, way to tell the difference is ask yourself if it's something that can be counted. If it's something that can be counted, it is quantitative data. If it cannot be counted, it is qualitative data. So things that we can't count are words, objects, pictures, observations, symbols. I'm going to even say like labels. Any of those things we cannot count, therefore it is qualitative. Things that we can count, numbers, statistics, quantities, amounts of things. Okay. All right, so get that one down and then we'll practice telling the difference between the two. We'll get some examples like previous section. Just hanging on the hook there. Mm-hmm. Okay. All right. So you don't have to write this down. Just some other examples here. Qualitative data, names of people, types of smells, colors, quantitative data, shoe size, weight, scores on tests. Gives you some examples. All right, so here we want to know, we've got 2 columns of information. It says the table shows sports-related head injuries treated in the U.S. emergency rooms during a recent 5-year span for several sports. Which column of data represents qualitative data and which represents quantitative data? So the first column is the different sports. The second column is the head injuries. Which of the 2 is qualitative? The first one, the sports, are qualitative. The categories of things are a good way to remember that. I'll just put qualitative there. Qual. Labels of things, anything that's definitely not numerical is qualitative. And then head injuries. Could we count head injuries? Probably. Hopefully we don't have to. But that's an example of quantitative data. That's something that we could do statistics with. We could do calculations on. I could calculate the average. I could calculate the range. I could calculate the median, right? Things that you've probably done in the past with data before. So if you can do that, it's probably quantitative data. Okay, next definitions all fall under the category of levels of measurement. There are 4 levels of measurement. And I'm just going to talk about them here. Don't write anything down just yet. I'm going to show you kind of a summary page. It's nice with all these and you can kind of rank them. You're going to see that as we increase in our level of measurement, we add more pieces to the puzzle, okay? So the lowest level of measurement we have is nominal measurement. Nominal measurement is only qualitative data. So if you've got quantitative data, it is automatically not nominal. Nominal is something that we can categorize, but it cannot be ordered. I'm going to put that on here, and it'll be on the next slide in a second. So like colors, for example, okay, they're qualitative data. They represent categories, but I can't order colors any way other than, you know, what I feel like looks pretty, right? Ordinal level of measurement is now something that can be ordered, okay? So it's qualitative data. It could even be quantitative data, but it's something that's ordered. So if you have like rankings of things, first place, second place, third place, fourth place, fifth place, even if they're categories, if it's something that can be ordered, it's ordinal data. And then if we calculate differences between data entries, like if we do have numbers, they're not actually meaningful. The other 2, we'll come back to that in a second, are interval and ratio. Interval level is, again, data that can be ordered. It could be, actually it can't be qualitative anymore. It's only going to be quantitative. The difference is meaningful, and here 0 is going to represent a position on a scale versus meaning nothing. So let me give you an example of what that looks like. If we talk about temperature, when we talk about 0, 0 doesn't mean nothing. 0 just means 0 degrees, right? Or if we talk about years, year 0 doesn't mean nothing. It just means it's a position on the scale. Something happened before it, something happened after it, right? So that's what we say is not an inherent zero. An inherent zero is what we get when we have a ratio level of measurement. Ratio level of measurement has all of the other little characteristics we've talked about, but zero means none. So if I have a basket and I say how many apples are in this basket, if the answer is zero, zero means none. So the numbers of apples in a basket would be a ratio level of measurement, because if there are zero, it represents none, and it's something that I can count. And it's quantitative data because it's a number that I can do calculations with. Okay, so what I want you to write down with this, and then we'll come back to our examples, is this. These are kind of those bullet point pieces of information I just kind of ran through. So nominal is what you can put into a category. Nominal will only be qualitative data. Okay. Ordinal, we can put it into a category and we can put it in order, and that could be qualitative or it could be quantitative. Interval, we can put it in a category, we can put it in order. If I subtract values, it means something. Like if I subtract years, 1980 minus 1970, there's a 10-year difference, and that difference would be meaningful for whatever we're calculating. This is quantitative data only. Okay. Also, the zero is arbitrary, which means that zero represents a position on the scale. And the example I gave you were years or temperature are going to be common examples of interval level of measurement. Okay. Ratio is all the things. Plus zero means none. And again, that's going to also be quantitative. I'll put that on there. Okay, so mostly what you're going to do with these is you're going to be given a set of data, a sample of information, and you're going to be determining, is it qualitative or quantitative, and then from there, which level of measurement does it fall in? Because eventually knowing what level of measurement it falls in is going to tell us what we can actually do with that set of information. Okay, about one more minute. We'll do a couple examples. That'll wrap it up for us today. Okay, so let me hop back here. All right, so let's look at these two first. And we'll do these ones together, like I said. So it says for each data set, determine whether we are either nominal or ordinal for these two. So we're kind of narrowing down the choices here for you. So the first one is top 5 U.S. occupations with the most job growth. So is that, first of all, quantitative or qualitative data? Qualitative data here, because it's categories of jobs in this case. So now I know it's either nominal or ordinal. The instructions kind of narrowed that down for us already. The next question is, can we order that set of information? It's ordered for us already, right? It's ranked. So the fact that it's ordered tells us it is ordinal, right? Okay, now looking at the next one, movie genres. Again, we've got categories, so it's qualitative data. Can we order those? Not really. Who's to say that action is before or after adventure, right? Unless you make your own rules up. So it's nominal. It's not something that can be ordered with any sort of numerical data. Okay? Questions on those? Okay, the other two that I want to talk about with you are these ones. So instructions here say we're either looking at interval or ratio level of data. So the first one is our years that the New York Yankees have won the World Series. If you're not sure between interval and ratio, think about the 0. That's the biggest difference between the two. A 0 in interval means a position on the scale. A 0 in ratio means none. So here we're talking about years. Is this interval or ratio, do you think? It is interval, because we do not have what we call an inherent 0. An inherent 0 means none. Okay. Last one, we've got 2016 American League home run totals. So the actual data that we're talking about is this kind of second column of information, the actual home run totals. So think about what 0 means. Would 0 mean that there are no home runs? 0 here means none. So if 0 means none, the answer is ratio. Okay, so last slide of the day. And there's another little kind of graphic here explaining the difference between them. I've got 4 samples at the bottom here. I want you to determine what level of measurement they are. Nominal, ordinal, interval, or ratio. Okay, you guys can work together if you want. I would actually love if you worked together. If we all talk, that'd be great. All right, so I'll give you a couple minutes. Find a friend, try those 4, label them, and then we're done for the day. Go. All right, what do we decide about highest grade level completed? Nominal, ordinal, interval, or ratio?
Ordinal.
Agree. Ordinal. So even though a number represents it, it's really a category when we talk about a grade level, but it is something that is naturally ordered. First grade, second grade, third grade, whatever. Gender. It's a category. We can't really order it. Nominal. Year of college graduation. As soon as you see years, it is an interval. And then number of years, that one's a little tricky. So 5 years, 8 years, 12 years, 0 would mean none, right? Ratio. Okay, that's it for 1, 2. All right, so Math Excel, you've got 1, 1 due tonight. 1, 2, what was our original deadline for that? Let's see. 1, 2 was originally due Thursday. Tomorrow I'll make it due Friday. So what's Friday, the 21st? I'll edit that in Math Excel today for you. Okay, so I'll do cell phone lotto. You guys have a little over 20 minutes if you want to work on either of those assignments. Yes? Inherent 0 is a 0 that means none. Good question. Okay, you can work on both of those. How's the scavenger hunt going? That's technically due by Friday, so you still got a few days on it, but make sure if there's any like little hiccups with Stark Street or anything, you're either asking me or calling the help desk or whatever. Do you have a question on that or no? Yeah. Okay, I can assist. All right, let me do cell phone lotto. You guys can